Okay, so I'm going to your group 17, right? Just to make sure. Okay. Okay, so what we're going to cover today is actually hypothesis testing. So remember in our last meeting, we go through in terms of how to do descriptive analysis. In your final report, you will need to do two types of analysis. One is descriptive analysis. The second one is hypothesis testing. In your assignment 3, you come up with two hypotheses, right? So we're going to learn how to do those testing so you can test for your hypothesis. I'm only going to do one of your outcomes. You're going to do that for your second outcome, okay? So this is the data set I've already sent you. In the data set, you should have participant ID, age, race, ethnicity, gender, and also the two outcomes at both timeline. B stands for baseline. You also have, hold on a second, P stands for post-test, okay? So I created a separate sheet for today's discussion. So what I did basically is just copy and paste some of the variables into the spreadsheet. For example, I have PID, I have race. I also calculate the total score of AAPI. I don't know what AAPI stands for, but that's your one of your outcomes, okay, at baseline and also post-test, okay? So remember, your person's response to each item doesn't give you much information. When we're doing hypothesis testing, when we're doing program evaluation, it really depends on how the measurement tell you to use them. In your measurement table for AAPI, I believe you highlighted that you will need to calculate a total score, and I think it's a 40 item. Is it 40 item? Let me double check that. AAPI, that will be, yes, 40 items. So you have 40 questions measuring a certain outcome, and basically you will have to add those 40 items for each participant to come up with a total score, right? The higher the score means the better in terms of the outcome of interest in your case. So what I did is simply calculate the total score for AAPI at baseline and calculate the total score for AAPI at the post-test. Again, how to calculate the total score, we've already covered that in our previous meeting, so I'm not going to go through that. Okay, now, so what we're going to do is do hypothesis testing, but before we start, I do want to cover how to develop graphs, because in your final assignment, you will need to develop graphs to present the data you have. Either it is demonstrating the racial composition, which is a nominal variable, or you're demonstrating comparing pre versus post on the AAPI score. So let's start with nominal variable. So when you're presenting nominal variable, that is variables with categories that no hierarchical in order. For example, race, ethnicity, gender identification, sexual orientation, those are nominal variable. They don't have hierarchical in order, okay? So what you need to do, then let's use race as an example. We have white, black, Latinx, multiracial, and other. We have 4 categories. You probably will have more in real life. However, if you look at the sheet 2, the code sheet that I developed for you, we only have 4 categories: white, black, Latinx, multiracial, or other, okay? That's exactly what we're going to do. Now, you have to count how many whites are among your participants. Remember, we have 24 participants in the mock data set. We also want to know how many blacks are among our participants, how many Latinx, how many multiracial are, okay? So basically, you will need to count how many ones, how many twos, how many threes, how many fours under this race variable, okay? So again, go back to the code book. 1 equals white, 2 equals black, 3 equals Latinx, 4 equals multiracial or other. So you can count right on the spot, or you can do it more strategically. You can sort it, and we've already covered how to sort it. You can highlight it, sort from the smallest to the largest. Click it, and you can see now all the ones, all the twos, all the threes, all the fours are clustered together. So what you need to do is highlight ones and then look at count. There's a count below. It says 6. That means you have 6 whites or 6 ones. For blacks, that's 2, right? So you can highlight 2s and you look at the count. You have 5. So put into 5 over here. For Latins, that will be 3. So if you can eyeball it, you only have 2 3s, so put 2 here. And multiracial order, you can highlight it. You have, that's the largest group, you have 11. So put in 11. Now you can, once you do this, what you need to do is just highlight it with categories also included and click insert. There's an insert tab and there is a bar chart tab, right? Oh, sorry, not bar chart, pie chart. And it will show up something like this, okay? Do not submit as it is because it's not APA style. It doesn't give you much information. So what you need to do is change the chart title, make it APA appropriate. There's also an add chart elements on your left-hand side, upper left-hand side. You can click it and there's a data label. The default is none. But if you scroll down, you can see it starts showing up counts within different places, okay? Personally, I like data code out. So if you select it, it will give you the label. It will also give you percentage. Percentage usually is better than simply the count because it gave you the relative information. And just play around with it, see what makes sense, and you can include it in your final report, okay, or final assignment. Now, to compare pre and post, using AAPI using chart, because AAPI is a continuous variable, you probably would like to use a bar chart. Now, what I'm going to show you is exactly what you shouldn't do when you're doing a bar chart. The reason why I want to show you this is because I don't want you to submit that graph and got points deducted, okay? So usually students will have the first step right. They know that, they will need to calculate a total score for pre-test and for the post-test, and they calculate it correct. But then they highlight it and then go insert bar chart. Okay, they will get something like this. If you saw something like this, that means you're making a little bit mistake, because if you look at this, what this tells you is that you basically give me the pre-test and post-test for each and every participant. Okay, so 24 participants, meaning we have 48 bars here. If you have 100 participants, you're going to have 200 bars. If you have 1,000 participants, you're going to have 2,000 bars. That's just too much information and not very informative. So if you think about it, what you really want to present to your readers is that after participating in the program, on average, does our participants' AAPI increase or not? So in this case, you actually want to calculate the average of the pre-test and average of the post-test after you calculate the total score, right? So what you need to do is, we already cover how to calculate average, so I'm not going to go through that. You simply just go to average, highlight it, hit enter, and do the same thing. So now you have the average pre-test API and average post-test API. You want to highlight it and you want to go to insert bar chart. Okay, now it makes more sense because now you only have 2 bars, one representing pre, one representing post. Okay, simply by eyeballing it, it seems that your program worked because there's an increase in post-test regarding AAPI, right? What we don't know is the differences between the two. Are they statistically significant or not? So we have to test it. Otherwise, it could be the case that you eyeballing it, there's difference, but it's actually not statistically significant. Still means that your program does not work. Okay. Now, we are, you can definitely play around with it. For example, you can choose whatever bar chart you want to show me. Add chart title, add chart elements on your upper left-hand side. You can do like add title, for example, access title. You can put in pre versus post. For that, you can do not horizontal, but vertical ones. You can put into the API score or change chart title to make it APA style. Just APA style. So okay, now, so we've covered how to do the graphs, how to do the charts. Now we're going to do the testing, because we see there's differences. It seems there are differences. We just don't know if the differences are statistically significant or not. So now, in order to do statistical differences, you know that, or statistical hypothesis testing, if you review the lab assignment step by step, the 8 clips and also the recorded lectures for statistical testing. I cannot remember which week we cover that. In any case, we actually, you should know that there are multiple tests you can do. You can do independent sample t-test, pair sample t-test, one-way ANOVA, chi-square, and correlation, different types of tests, okay? So now the important thing is that to pick the appropriate test for program evaluation, it depends on 2 major factors. One is your evaluation design. The second is your outcome of interest, the level of measurement of them, okay? So in this case, your design is a pre-test, single group pre-test and post-test design. What does it mean? That means you only have one group. Okay, you're not withholding your services to a group of people who are otherwise eligible for your program in order to have a control group. Okay, you're not Pfizer, you're not Moderna, you're not Johnson & Johnson. In order to check, in order to examine whether the vaccine works or not, you're giving a group of people placebo and the other group of people the vaccine. You're not doing that. Because of ethical reason, you decided that, you know, for everybody who are eligible and willing to participate in the program, you give them the services. The only thing you do is that you give them a survey, pre-test survey before the services and access survey or post-test survey after the services. And you're trying to compare the pre-survey versus a post-survey to see whether your outcomes of interest, API in this case, and I cannot remember the other one, whether it has changed or not, okay? And your outcome of interest is a continuous variable, meaning it's a score, okay? So because your outcome of interest is a score, you are comparing the same people on their pre and post. Your design is a single group pre-test and post-test design. We're going to use pair sample t-test, okay? So in our meeting today, we're only going to cover how to do pair sample t-test. I strongly encourage you to download the clips that I uploaded so that in the future, if your design change or your outcome of interest change, you can still do the analysis accordingly. But for today's meeting, we're going to focus on what's pertaining to your assignment, okay? Now, to do pair sample t-test, you will need to go to data, and you will need to activate the data analysis toolpack. So Paige, were you able to activate it? Okay, good.
I restarted my computer like 2 different times and it ended up going up there. So
yeah, I think another student also experienced the same issue. Like you
I actually got it done that evening and turned it in. So
okay, cool. So basically, you will need to because you have already done your lab assignment, so you should have it activated. If you haven't activated, review the clips. It tells you exactly how to activate data analysis, okay? If you encounter issues, just like what Paige did, you just turn it on, turn it off, you know, get a sleep, and then see if life change tomorrow, in the next day. So go to data analysis, and then go to find pair to sample for the means. That's pair sample t-test. Click OK. It will ask you what's your variable 1 range, what's your variable 2 range. What does it mean? That means what's your pre-test, what's your post-test, okay? So for variable 1, you simply just highlight your data range. Now, please close attention that I also include the label here, okay? I didn't just highlight the data, I also include the label. The reason why I include the label is because if you include label when you spelled out the result, you will be able to identify which one is pre, which one is post. Okay. Do the same thing for the variable 2. I also included a label, highlighted, and then because we include labels, you want to check the label box. But what it does is that it tells Excel that, well, the data range I just gave you include label. Okay, now the hypothesized mean difference you want to put is 0. What does it mean? It means that that's your null hypothesis. The null hypothesis is that your program does not create any changes in terms of AAPI in the pre versus post. So it's going to be 0 changes. Alpha, that's the p-value. The convention is 0.05. It's p if your p is lower than 0.05 is significant. If its p is larger than 0.05 or over 0.05, it's not significant. Okay. Now click OK. The result is going to be here, and let's just take a look at it. If you look at this, this is exactly why I include the label, because it will tell you basically this column is for baseline, this column is for post-test. If you don't include label, it will simply show variable 1 and variable 2. And you just need to double check which one is which. Okay, so that's the reason why I include the label. It gives you the mean, which we calculated, 98.88 and 141.58. Okay. It also gives you variance. What's variance? Variance is basically the square of standard deviation. We've already covered how to calculate standard deviation in our previous discussion. And we also covered that you will need to present standard deviation in your result section for if your outcome of interest is continuous variable. I should say this, for every variables that are continuous variable, you need to present mean and standard deviation. That's the bare minimum. Now, observations give you what's the sample size in each different time frame. So what that means is that you have 24 people in your baseline and 24 people in your post-test. Okay, what does that mean? That means nobody dropped out from your program. In real life, you're likely to have 24 people at your baseline, and maybe 20 people in your post-test. Okay, that means 4 people dropped out. It also gives you a good indicator for red flags. If you have 24 people at baseline, and let's say in your field placement, you're evaluating your a program, a caregiver support program, right? You have 24 families or parents who participate in the program at baseline. The second time, maybe 22 people show up. Sounds good. But starting from the third session, only 10 people show up, or even 2 people show up. That is a red flag. What does that mean? That means that your program, either the scheduling is wrong, people cannot participate, or the program is just not helpful, so people dropped out, or too burdensome, too excruciating, so people dropped out. Okay, that's the reason why this is good to look at. In this case, it's pretty good. Nobody dropped out. Now you will need to focus on p-value two-tail. Always look at two-tail. The two-tail is 1.36. You probably would ask, well, 2 questions. One, its probability. How come a probability is over 1? The second thing is that if it seems that it's over 0.05, so it's not significant. Well, if you look closely, you have E negative 16, right? What does that mean? That means the p-value is so small, they cannot present it here. So what you need to do is move the decimal to your left for 16 spaces. So instead of 1.36, it's actually 0.00000000001. 136 or something like that. Okay, so that's exactly that means that your p-value is smaller than lower than 0.05 is significant, and the direction exactly what you wanted. I'm assuming that API, the higher the better. So your program actually work in terms of increasing people's API. Now, if API is the higher the worse, then that also means that your program is doing harm and it's significant. Okay, if it's over 0.05, meaning that there's no difference between pre-test and post-test in terms of API. Now I'm going to give you some statement that you can use for analysis section and result section. For analysis section, for a hypothesis testing, you want to say something like this. For hypothesis 1, state your hypothesis. Because we used a single group pre-test and post-test design, and our outcome of interest X as measured by AAPI is a continuous variable, we conducted pair sample t-test. With the same rationale for hypothesis 2, we conducted the same analysis. Okay, I'm assuming for your second hypothesis, the second outcome of interest is also a continuous variable. Now, for the result section, you can say something like this. Based on for hypothesis 1, based on our based on the result of paired sample t-test with p lower than 0.05, we were able to reject the null hypothesis, and that our participants demonstrated significant increase in X outcome as measured by AAPI in the post-test as compared to the pre-test. Okay, you don't need to do much interpretation, just tell me exactly what you found. Okay, if it's not significant, because I'm not quite so sure for the second outcome, is it going to be significant or not? If it's not significant, you want to say something like this. For hypothesis 1, based on the result of pair sample t-test, with p-value over 0.05, we were not able to reject the null hypothesis, and that there's no significant difference between pre-test versus post-test on our outcome of interest X as measured by AAPI. Simple as that. Okay. Now, I'm sure if you show fifth graders this clip, they can do the statistical testing. Okay. If they know how to highlight, which range to highlight, which button to click, they can do that. Okay. So the most important thing that I'm going to look at is your implication and discussion section. So basically, you want to explain why your program works or why your program does not work. Okay, go back to your logic model, go back to your theoretical diagram. If it worked, what exactly worked? Why do you suspect, based on your familiarity with the program, your critical thinking, your expertise as a social worker, why you think the program works? Specifically, what activities may contribute to that? What elements in the program may contribute to that? Okay, discuss about that. How you can sustain the impact. If it's not significant, why the program failed, at what aspect? Okay, based on the theory, based on your understanding of the program, based on the logic model, how you can improve the program. That's what I'm going to look at for the final, for the implication section. Okay, that's pretty much about it. Any questions for me for the final assignment?
Not for me.
Okay, Paige, you're good?
Yeah, I think so. I'll probably rewatch this again. I think
Yeah,
it's
I will.
helpful I think it's helpful that we did our other final assignment before this, because it gave us some practice, at least me. So
Okay,
I don't think I have any
cool.
questions. I appreciate your time.
Okay, thank you very much. So